introduce today's presenter, Dr. Thomas Swetnam. Tom is a Regents Professor Emeritus, which I can never pronounce, at the Laboratory of Tree Ring Research, University of Arizona, down in Tucson. He grew up in northern New Mexico. He received his undergraduate and graduate degrees at the University of New Mexico and University of Arizona. Tom has studied land use history, forest and fire ecology in the western U.S., Mexico, South America, Siberia, and Russia. Using dendrochronology, which he'll go into, it's tree ring research, Tom and his colleagues have reconstructed hundreds of years of climate and fire history in southwestern forests and giant sequoia groves in the Sierra Nevada. Tom's work focuses on applications of science in the management of natural resources and in promoting effective science education and communication with land managers and the public. He has testified to the U.S. Congress on multiple occasions, was appointed by the governor of Arizona to 2 advisory boards, and was appointed by the President of the United States to the first board of trustees of the Valle Caldera National Preserve. Tom's scientific honors include the Harold C. Fritz Lifetime Achievement Award, Tree Ring Society 2016, Harold Biswell Award for Lifetime Achievement, Association for Fire Ecology 2016, American Association for the Advancement of Science, Fellow, elected 2015, Henry Cowles Award, Association of American Geographers, 2002, and William Skinner Cooper Award, Ecological Society of America, 2001. Tom now resides in Jemez Springs, New Mexico, where he and his wife Suzanne enjoy a busy retirement life of gardening, community volunteering, and tree ring dating of historic buildings, archaeological timbers, and fire scars. We're pleased to have Tom with us today, and with that, I'll turn it over to him.
Okay, thank you, Rachel. I'll share my screen here and get started. So, thank you very much, Rachel, for that introduction. And thanks to Fire Adapted Communities New Mexico for inviting me to give this talk. It's a great pleasure to talk about this landscape in particular, where I'm living now, actually where I grew up and moved back here in retirement. And in the last 15 or so years, we've been doing more intensive studies across this landscape to try to understand how people lived on this landscape for centuries with fire. It's such a great place to study human fire interactions. It's such a rich landscape of people and places and climate variability. So I'm going to talk about that and share with you the insights that we've gained from our tree ring studies, archaeological studies, and ethnographic interviews with Jemez people to learn about fire and how they used fire and how they understand fire, and use the tree rings to kind of interrogate the past to learn more about fire and human interactions. So here's the briefest summary of my key points that I'll be making today. There'll be others, but it basically, it's this understanding that I think is important, that we recognize that the landscapes we're on in many places across the Southwest have been highly altered over time from humans, Native American people, especially where the numbers of people were high in forested landscapes. And there's quite a few places in New Mexico like that, where Puebloan people lived right within forested landscapes, as well as Apache and Navajo people. When people live in forested landscapes, they use it. They use the wood, they use it for fuel wood to heat their homes, their hearths, and they cut timbers for their roof beams. And they set fires, they use fires for various purposes. And what we've learned, and I think it's kind of a general message across North America, is when we look at how people used fire in the past, it tended to make the landscapes more sustainable over time. It reduced the effect of climate variability. It sort of buffered the influences of wet and dry conditions, driving larger fires that we see today. So human interactions on the landscape actually can have a beneficial effect in terms of sustaining forests and livelihoods. So let's see if I can get this to continue here. Yeah, many of you have probably seen this video. It's a time-lapse video taken from near from Santa Fe, looking toward the Jemez during the Las Conchas fire of 2011. And so this fire was a wind-driven extreme fire event. If you've been across this landscape, you've seen the effects of it. It burned 43,000 acres that first day. And this was the kind of fire that we're seeing more and more of in the Southwest. And undoubtedly, the causes of these really extreme fire events is both climate variability, warming temperatures, extreme droughts, and changes in fuels. The effects, if I can get this to change, let's see here. There we go. So the effects are pretty striking and profound. On the east slope of the Jemez Mountains, on the Pajarito Plateau, there's tens of thousands of acres that basically all or nearly all the trees have been killed. And these landscapes are not coming back to forest anytime soon, and maybe not for centuries. With warming temperatures, especially, and the lack of seed source, we're not seeing regeneration in these landscapes. So we're seeing type conversion at a really huge scale. Again, and the combination of fuels changes and climate changes are responsible for these extraordinarily high severity fires that are occurring on the landscape today. They're burning over, and here's where the questions come in. They're burning on landscapes here in the Jemez where there's a high density of archaeological sites, one of the highest densities of archaeological sites in North America. Literally thousands of small 1 to 2 room structures and dozens and even hundreds of larger villages over the landscape. Here's my friend Craig standing on the rim of Cochiti Canyon, and on the left there you can see a little yellow square, and that is actually a small village site on the mesa across the way where they had put down some hay to try to prevent erosion on that little village site that was completely burned over by high severity fire. So when we see this today, we're now seeing high severity fire burning over village sites and actually damaging and destroying some of the archaeological artifacts that are on the surface. And we have evidence that these kinds of high severity fires have not occurred on those village sites in many, many hundreds of years, if ever. It poses the question, why is this happening now? And how did people live in this landscape in the past when there weren't fires like this before? And why weren't there fires like this before? So these are some of the questions that arise. And again, it's a great place to study these changes because the density of human sites is very high here on these landscapes, including big villages like this one known as Quastiyuqua in the Jemez, an aerial view on the left, and then a architect's view of what this multi-storied village may have looked like. More than 1,500 rooms, and they're living right in Ponderosa pine and pinon juniper landscapes. Actually, this artist rendition on the right, I think, is probably not quite accurate in the sense of what we've learned is that the trees probably didn't even come this close to the village. After living in these places for 300, 400 years, most trees were cut and had been taken away from the village and used for fuel wood long before the village got to its maximum size. So there are many villages like this across the southern plateau of the Jemez and likewise on the Pajarito Plateau. And here, this kind of cuts to the punchline of one of our studies here was how many people lived in this landscape. And the number that we come up with is about 5,000 to 8,000 Jemez people were living in these villages prior to about 1650. And I'll show you talk to you about the methodology for getting to that number here in a minute. But a lot of people is scattered out around the landscape, living here for probably since 1300 or 1400 until the 1600s. So several hundred years of occupation of this landscape, growing their fields and crops and traveling between their villages and living with fire. In addition to the villages, the big villages that have hundreds to thousands of rooms, there are many thousands of these so-called field houses. These are 1 and 2 room structures that are distributed across the landscape. These are thought to be mainly seasonal houses where families would leave the villages in the summertime and go grow their crops out in among the trees in the forest, in the openings in the forest. So there were many fewer trees and there were many openings. And so people could actually grow corn, beans, and squash in forested landscape. And these houses attest to that, the people living there. And there are many other indications of farming there, including old fields and check dams where they were using water from the rainfall to feed their crops. So a heavily used landscape for hundreds and hundreds of years in ponderosa pine forest with fire occurring in these landscapes while they were living there. So one of the assumptions that many of fire historians have made, including me for decades, was that because there's so much lightning on this landscape, lots of lightning and plenty of people, as my friend Craig Allen wrote in this book chapter about 20 years ago. And this image here is actually lightning strikes over the Jemez Mountains over about a 20-year period. Each one of those little dots is a lightning strike. And the message here was that there's so much lightning on this landscape that you wouldn't need people to generate very high fire frequencies. And this is true enough in the sense that, and we've found that when the mesa tops here were depopulated after 1650, fires did continue, but the pattern of fire changed. And that's what we've learned from these recent studies, is that the kinds of fires, the extent of fires, and the frequency of fires actually did change when people were no longer living within these forests. So that's part of the story. So the team that I've worked with in the last decade and a half or so on this project that we call Fire and Humans in Resilient Ecosystems, this is funded by the National Science Foundation, and is led by my colleague Chris Rose at Southern Methodist University, as well as Matt Liebman at Harvard. And we had a really great team and a diversity of talents and skills here, including our ethnographer, anthropologists, John Welch and TJ Ferguson from Simon Fraser and University of Arizona. And Rachel Lohman and Bob Keene helped us working on modeling aspects of this. And perhaps most importantly, our collaborations, interactions with Jemez Pueblo collaborators. This includes Chris Toya with the Natural Resources Department of Jemez Pueblo and Paul Tosa. And this is really, I think, one of the more fun and interesting parts of the project has been learning from the Jemez people and how they viewed fire and how they've used fire in the past. And one of the approaches here was to interview elders at the village of Walatoa, Jemez village of Walatoa, and talk to them about how they understand fire, how they've used fire in the past. And much of this work is being developed for publication. But we've learned quite a bit about how the Jemez viewed their landscape. And here's one conceptual diagram that's included in one of the papers, the 2021 Proceedings of the National Academy of Sciences paper. And here, as you kind of see, it's a sort of geographic expansion of how people used fire and the different uses of fire as increasing distances from the village, out into finally from the home that is at the village, right out to the forests and woodlands, many different uses of fires. And so what we learned from this is that fire, of course, is an essential part of Jemez culture, the use of fire for lots of different purposes. What we haven't learned is specific techniques for firing the landscape, like say broadcast burning of forested landscapes or woodlands. These are practices that were discontinued when the Jemez Pueblo people were moved out of and migrated out of the mesa tops down to where the village is today, down in the low part of the Jemez Valley. And so the Jemez have been excluded from managing the forest and living in the forest for about 350 years. As a consequence, there's not a lot of traditional information or knowledge, at least that's been shared with us, about how specifically people burned in forested areas, how frequently they burned and how large the fires were and what sort of techniques they used. So this is where the archaeological and the tree ring and the paleo perspective is actually important, because to learn some of the specifics about fire frequency changes and fire extent changes and seasonality in the woodlands and forests, we have to turn to the paleo record more than even the traditional knowledge record. So we've done that, and to start, we began with some archaeological studies to try to understand the numbers of people that were on this landscape. And here we were able to use this new technology, LiDAR, the laser technique of bouncing laser beams off of the ground and recording a three-dimensional model of the surface of the ground. So that's the image on the right of the Bigfoot ruin, and on the left is the oblique aerial view. And from the LiDAR, you can actually get really high resolution measurements of the volume of the rubble mounds. So this enabled us to get, much higher resolution measurements of how big these villages were. And with a calibration of the volume of rubble mounds to how many rooms would that account for, and from that to how many people would live in so many rooms, based upon studies of existing pueblos today, the archaeologists are able to come up with an estimate. So the estimate is based upon how many rooms in the Jemez there were at particular times in the past. So to get a handle on the timing, so the question is, well, how many people were there, and how did it change over time? One of the main questions was, well, when did people depopulate? When were these village sites depopulated? They were never abandoned. The Jemez people returned to these places for lots of reasons. They're sacred sites. They have shrines. There are many people buried in the ruins, many Jemez people. And so these are not abandoned sites, but they were depopulated and people were no longer living there full time. So our question was, well, how do we tell when these villages were depopulated? What's the timing of the depopulation, so we can then compare that with the fire history that we reconstruct from tree rings? So the dating of when these villages were depopulated was accomplished by measuring, by sampling the pottery, the ceramics, and then by the style of ceramics, you can estimate what is the last used period by looking at ceramics that are on the surface. And so the basic message there was that, yes, these were depopulated probably in the mid to late 1600s. The other way, of course, for dating the structures and when they were built is from the tree rings. And there's quite a bit of surface wood still remaining on some of the Pueblo sites. For example, you see these downed logs here on the right, and this field house. And then there's actually a pot hunted ruin there on the left with a beam sticking out. And so we've done my laboratory, the tree ring research, and archaeologists in the Jemez, and I have done a fair amount of tree ring dating also of the vigas that were in these structures to learn when the trees were cut. And so that gives us a date of when the houses were built. The other method that we used is by sampling living and dead trees growing on and within the village sites. So in the center there's one of the villages, and shown with LiDAR, and all the little red triangles are the locations of tree ring samples collected within the village site. Josh Farella, my graduate student on the left there, approaching a fire-scarred tree for sampling. And then I think maybe that's Chris Gitterman or someone else on the right. They're cutting a remnant chunk of wood in one of the village ruins. So in addition to sampling living trees, we're sampling dead trees. And the question we're answering is, when did these trees establish in the village? And especially when we could find them, which we found quite a few, when did trees that were growing right within room blocks establish? So the age of the tree, the germination date of a tree growing within a collapsed ruin would give you a minimum time since that room was occupied, understanding that the roof would have to collapse over a decade or two, and then a seedling would get in there, so there's some lag between when the trees get established right in the ruin. But we did quite a bit of this so-called terminus antiquum dating by sampling trees growing right within structures, and in that way we're able to get a handle on when the villages were depopulated. And so here's one of the figures from one of their papers showing the age of the establishment dates of trees in multiple different of the large villages. And you can see that mostly the trees start establishing in the villages after the 1630s, and especially after the 1650s, we get trees establishing within these village sites. And so that is giving us a time frame when these villages are most likely depopulated. And this fits the historic record. We know that here in Jemez Springs, this church, this mission church, was built in about 1619 to 1620. the Mission de San Jose, and right here, Jemez Historic Site in Jemez Springs. It was built in the 1620s, and the pueblos were congregated off of the village, off of the mesas down to this one village, pretty much in the 1620s to 1650s. And so we know that, and we also know that the one of the priests there, Geronimo Zarate Salmaron, who actually was the main engineer and led the construction of this village by this church by the Jemez, he said that he had baptized 6,500 and 66 souls, a pretty precise number that we always were kind of curious. Is that, is that an underestimate? Is that an exaggeration? What is it? Well, it turns out it's probably pretty accurate. It's like right in the middle of our best estimates from the LIDAR measurements of the rubble volume, and then equating that eventually to populations. And we come up with two estimates: a conservative estimate of which is based on, like, say, fewer numbers of people per numbers of room, to larger numbers of people per room, architecture 50% and 80%, and that brackets a population of between 5,000 and 8,000 people before about 1650. And then after, the 1620s or so, with the priests, we have historic records. And from there, you can see this precipitous and very tragic decline of Jemez population from somewhere between 5 and 8,000 people down to the low 100s in the 1700s and 1800s. And this was due to the introduction of European diseases, the hardships imposed by the harsh Spanish rule in the early decades, and by increasing attacks by Apaches and Navajos and predation upon the Jemez and their pueblos. And so the population really crashed after that time. So before 1650, lots of people living on this landscape. After 1650, very few, almost none. There were still Jemez people traveling across these landscapes up to their sacred mountains, but no people living, not a lot of people living in the forest. So the question is, what was happening with the fire history during and after these periods, during a heavy occupation of these landscapes, and then after the landscapes were pretty much depopulated? So we turn to fire scars, and of course they can give us a timing of past fires by looking at these scars, the wounds within the boles of trees, and tree ring dating them. We can date both living and dead trees, and by piecing these records together, we can get fairly detailed histories of the ages of trees and the fires. So here's a diagram that shows kind of both this terminus antiquem idea of when trees established within the village ruins. Those are the green trees on the right here. You can see these trees that have green lines. These are their time spans, and they're trees that were establishing after depopulation. And there were fires. The little red tick marks are the fire dates. Okay, so the timeline is running to the present right here. And then these trees here are trees that were actually below this cliff face, away from the village, and they actually show some older trees that were growing down there below the cliffs, and also some fires that were occurring. So this is like probably ashes and kids playing with matches right next to the village, starting fires right below the cliff there. But the village proper, we have zero evidence of fires burning within the villages. There's no evidence, ethnographic or archaeological, of the villages themselves having ever been burned over and then abandoned, or burned over and rebuilt. Okay, so the village sites, we think, were pretty darn fireproof because they had 300 years of people living there. And so there's very little fuel wood for probably some distance away from the village sites, and every pine needle was probably being used for starting fires in their hearths. So we have a really extensive network of fire history sites in the Jemez Mountains. It's the most extensively sampled fire scarred and age structure landscape, one of the most in North America. We really know a lot about the fires here, and it's not as some have suggested that our fire history sampling is non-random, or it's biased. In fact, we have very systematic sampling across this landscape, covering all ranges of elevations and forest types and aspects and slopes. We have really extensive sampling in one place, the Monument Canyon RNA Research Natural Area, which is shown here in the center with a square. There's that one is a gridded sampling over about a square mile, where plots of trees are sampled on plots in a very systematic fashion, and we've reconstructed the fire history in great detail there. Well, cutting right to the quick here on the overall general picture we see over the whole Jemez Mountains, and I'll drill down here in a site example here in a moment. But this is a composite of the numbers of trees scarred per year going back to 1500 over the whole Jemez Mountains. So that's like 1,377 trees. It's a huge landscape and a lot of fire scarred trees. And the composite there shows this amazing pattern of lots and lots of fires before 1900, relatively few fires after 1900, and that coincides with the advent of livestock grazing, especially huge numbers of sheep were brought into the Jemez. Over 300,000 head of sheep were brought into the Valles Caldera and on the mesas here south of the caldera after the 1870s, 1880s. They're huge sheep herds which ate the grasses, which carried fire, and they also made lots of trails, which interrupted the fires. And then the Forest Service began to put fires out after about 1910. So lots and lots of fires. But the interesting pattern here, which we interpret as the signal of human influences on these fire regimes, is what we see before 1650, the yellow and orange periods here, is that there are relatively few widespread fires. These are the fires that are scarring on more than 25% of the trees, and at least two, a minimum of two. And what you see is very few of these large widespread fires. And after the depopulation period, after 1650, there's many more widespread fires, significantly more widespread fires. And we've shown that this is statistically a very significant pattern. It's not tied to the sample size. It's the number of trees that we've sampled does decrease through time. But interestingly, in this time period, when you're looking at all the fires recorded by any tree, many small fires. You can see that in that graph. There's lots and lots of little red bars there. There's lots and lots of fires that only scar one tree. And so there's this pattern of lots of fires that didn't spread very far, that are recorded on only one tree, and the intervals are very short. So this is the pattern. When people are living on this landscape and using the landscape and actually setting more fires, they're setting fires, but they're adding to what's there from lightning, but the fires don't spread very far. They just burn around a few trees. And then after people leave around 1650, very few people left after 1650 on these mesas, then the fuels start to build up over time and the fires spread. They become widespread fires. They're still low severity fires, but they're very widespread fires. We see this pattern even when we look at sites, individual sites, when the sample size is fairly constant over a long period of time. So we have a few sites with very old wood, like this site on the East Fork of the Jemez River. There's wood here going back into the 1300s. So these are old remnant stumps and logs laying in rocks that have survived many fires and decay, and they have fire scars on them. And sure enough, in this time period before the colonial period, before the congregation of the movement of people off of the mesas, there's lots and lots of little fires and relatively few widespread fires. And then after the depopulation of the mesa top, we get free range fire period. We call a free range. These fires are just there. The fuels are building up over 5 or 10 years, and then the fires are widespread. The free range fire period, when there's many fewer people on the landscape. And then last, the fire suppression era is the livestock grazing, and there's also, of course, logging, which is occurring in that time period, and that also then changes the fuels. So we've summarized all this into different time periods, and there's descriptions of these. This work is described in a proceedings of the Royal Society paper, and I think I've asked Rachel to put a URL for a Dropbox folder where the publications that describe this work are located, and you can access this. And there's probably 12 or 15 papers in there that describe this work and related work. But just to summarize again, it's when people are using the landscape and using the fuels, and burning, setting fires, lots of small fires. When people leave and there's still lots of lightning and nobody's putting fires out, they become regular 15, 10, 5, 10, 15-year interval between fires and widespread fires. And then until we get to the final disruption of the fire regime. Okay. Shifting a little bit here, the other thing that we see with our fire history studies, when we compare the fire dates over landscapes, over really large landscapes, in this case, the whole Western United States, and looking at the 15 largest fire years from fire scarred trees all over the Western United States, where me and many colleagues have studied fire scars, and you compare those to a drought area index. So this is a drought area index derived from tree ring width chronologies. So this is a reconstruction of drought history, is the black line there. And you plot the big fire years on that drought history, the red years, and you can see they're mostly the high index years, that is the driest years. And then the small fire years are the blue ones. So this index of this drought area index is very well correlated with area burned in the Western US. You can see the red line on the outside here is the area burned compared to that index. Well, when we do what we call a superposed epoch analysis, we ask the question, what was the average condition during a fire year, the zero lag year here? And the average conditions was drought, right? And then what are the average conditions the year before? Well, the average conditions the year before are wet. So these are the lagging years preceding the fire year, and the fire year and even a year after continues to be dry. So that is what we call the canonical pattern over the Western United States. The canonical pattern. It's repeated over and over, where wet-dry switching drives widespread fire years in the Western U.S., especially in these dry pine forests. Well, it turns out that when you zoom in on landscapes and you do these superposed epoch analyses, and you especially zoom in on landscape where humans were living and using fire and time periods when Native American people were living in those landscapes, it turns out that the canonical pattern disappears. And so we've done a study looking at different landscapes in the Chusca Mountains and Navajo landscape, and then the Jemez, and also in Apacheria down in southern Arizona. And what we see as a general pattern is that during the human occupied period, the wet dry switching is no longer really operative. People are overriding this wet dry switching pattern. They're buffering the influence of climate. They're setting so many fires that the system is less sensitive to the switching of wet and dry. So from this, we take the point that when people are using landscapes, it kind of mitigates and it reduces the effects of high variability in climate, which we're seeing now. Okay, last couple of points here. One is that the changes in the landscape are very obvious. This is a big ruin up on the mesa top in 1904 or 1900. And you can see it's still pretty sparse, but there are some trees coming in. And today there's many more trees. So the fuels have greatly increased on these landscapes. We can see this over and over in repeat photography studies. Here's a 1904 panorama that I just came across, these photos from the Jemez Forest Reserve report. It's a view looking north toward Redondo Peak from Los Griegos. And what you can see is a lot of open landscape, especially focus here. This is all called South Mountain right here. And notice how much grass you can see underneath the trees on this mountain here. And also down on Banco Bonito, these are forest landscapes now that are very, very different from that. And here's a photo from that, from within one of those stands from that 1904 reserve report. And then here's another view. This is not the same perspective, but you can see, and this is actually before the Las Conchas fire and the Thompson Ridge fire and the Cerro Grande fire. So there's a lot of mostly looking unburned here, but notice how much more trees there are in these landscapes in the past, I mean today, than there were in the past. Here's a more modern photo taken from Los Griegos looking toward Redondo. And again, you can see how the forest is closed in on that north slope of South Mountain. And then in the foreground, this is fire burned areas from the Las Conchas fire and the Cerro Pelado fire, recent fires that have burned on this landscape. Again, the papers that describe a lot more details of this are available, and you can find them in the URL I think that Rachel has put in the chat. And this is just some more of them, led by Chris and Matt Liebman in particular. Um, we've drilled down, and I'm just kind of summarizing and skimming over a lot of the results of this work. So if you are interested and want to read more, please do visit that URL and you can download. The last thing I wanted to say is that this general understanding that landscapes have changed over time, in particular that human influence, human uses of fuels, wood, and human uses for timbers for construction has gone on for centuries in New Mexico. And there's so many villages and towns where there's hundreds of years of people drawing in fuel wood from as close as they could get, and then getting farther and farther out. I'm struck. When I've been to the photo archive in the Museum of New Mexico, the Palace of Governors photo archive, how many times I've come across photos of burros bringing fuel wood into the plaza in Santa Fe. It was such a common sight throughout the late 1800s and early 1900s. Here's a couple with fuel wood on the plaza, and then also even some of bringing in vigas, bringing in timbers. The quantities of timbers used is amazing. I mean, roofs were being replaced too, because before they had tin roofs, these old Viga roofs had to be replaced every 50 to 100 years, so they were replaced multiple times. And when you look at old photos from Santa Fe, again, you see this striking difference between then and now. So here is a comparison of an old photo, 1866, and look at the foothills. This is the St. Francis Cathedral there and there, and look at the slopes here and the foothills and the lower slopes of the Sangres in the back, and see how many fewer trees there are up in that landscape as compared to today. Okay, and so this is what is often referred to as a shifting baseline syndrome. I'll bet that many people that live today in these landscapes here, don't realize fully how closed in and many more trees are there today than there used to be, because for hundreds of years people were cutting fuel wood all around Santa Fe and timbering, and there were fires also. So notice here, this little peak right here is this little peak right here, this mesa over here with multi-million-dollar homes, Santa Fe homes, embedded within a wall-to-wall pinon juniper landscape, many of those dead now from drought and beetles. And in the past, it was a much, much more open landscape. And here's another example. This is one of those bird's eye view maps, which were really popular in old times. It's kind of an oblique view of Santa Fe from 1882. And of course, it's just an artist's rendition. But notice this artist had very few trees down in the foothills of Santa Fe. So this is a story, that is shown in photography, repeat photography from around Santa Fe, and from aerial photographs. This is from one of Ellis Margolis's papers, a 1935 aerial photograph of the Santa Fe watershed. And notice here, this slope is a grassy slope with a lot of cleared area. And then you come to 2005 and, it's closed in with trees. So the general point is that these landscapes have changed. People used them heavily in the past. They used fuel. They actually overgrazed and they overharvested commonly. And that's not where we want to head today. It's not what I'm arguing. I'm not arguing for going back to grazing a lot of sheep or clear cutting forests, but it is true that people used to live in these forests and they didn't burn up. And now we're losing homes and houses and livelihoods. And there is an approach to this, and it does involve mechanical thinning. In many places it's necessary, such as this place. So you see many stands with his dog hair thickets, many trees in the understory. It is possible to remove that understory and keep the overstory. And it is possible to do prescribed burning safely, despite the tragedies of escaped fires and mistakes that have been made. We know that we can use prescribed fire safely. It is used safely almost all the time. And we need to learn from the past, and I think we are, but we have to include fire because it's the most efficient way to deal with these fuels, and it's the way the ecosystems are adapted to dealing with overabundance of fuels over time and maintaining more open stand structures that are more survivable over the long term. So just the last comments, just to reiterate, it's true that um, reduced fuelwood harvesting and suppression of wildfires has led to closed canopy coverage, and it's probably more closed canopies now in many places in New Mexico than has occurred in many hundreds of years. Um, and there was a way to reduce the severity of wildfires by removing small diameter trees in the past. This is how they did it. This is how they were able to have pueblos situated within ponderosa pine forests for hundreds of years. You can hear in the background here, I'm in a parking lot in Jemez Springs, and fuels do matter, folks. So I'll end it right there. Thank you.
Thank you so much, Tom, for that really excellent presentation. And I'm looking forward to the opportunity to ask you some good questions as well. Just a reminder for everyone in the audience, if you have any questions for Tom, please go ahead and pop them in the chat. We're also a small enough group that if you would like to ask your question verbally, you can go ahead and raise your hand and we can do it that way as well. So to kick us off, Eleanor had a question wondering if the depopulated sites that you referred to are protected, if you need permission to get into them.
Yes, yes, definitely. They are protected. Most of the large village sites in the Jemez here on the Southern Plateau are on Forest Service lands. And if you're going to do any kind of scientific work on there, you have to have permission and be permitted, which we were. And the Forest Service does direct consultation with the Jemez Pueblo tribe, and for particular, Chris Toya is like one of the lead natural resources and cultural resources people that the Forest Service consults with. So they are protected, and for the most part, I mean, I think there's a few sites that are on private land, but mostly they're smaller structures. And of course, then there's Bandelier National Monument, where much of the archaeological materials are protected.
Great, thank you. And I'm going to kind of pivot off of that question as well. I know that you've done a lot of work in this area with oral histories as well as kind of what we think of as more Western science research. So just wondering if you've worked with the people of Jemez Pueblo, either to access these sites or to put together an oral history, which goes together with your dendrochronology research to strengthen and build off of one another.
Yeah, it's indeed. A couple of our team members, John Welch from Simon Fraser University and TJ Ferguson from University of Arizona, are anthropologists, ethnographers, and they conducted I think more than a dozen interviews of elders in Jemez Pueblo. And we're specifically, asking them to share, if they would, any of their knowledge and understanding about fire. And they did. And so much of that work, we summarize a little bit of it in our published papers, but there's more works yet to be published from Doctors Ferguson and Welch. But in general, what we learned from the Jemez is that indeed, I mean, they recognized fire as like really an essential cultural tool. And no doubt, they recognize that they were using fire in their agriculture. They had to be. They do today. They use fire in their agriculture in the village area where they live now. So if you've been to Walatoa or Jemez Pueblo, it's down the valley. It's down in, pinon juniper and lower elevation. It's out of the main forested area. And so their fire use there, their traditional fire use there in the landscape is mainly burning ditches and maybe burning a little bit of the chaff and the dead plants or the corn plants after the season, the growing season. So that's about the limit of their fire use today. Sadly, I mean, as far as I understand, there's no traditional knowledge remaining. There's no historical or oral tradition knowledge or stories that have been told. I'm not going to say that it doesn't exist, but it hasn't been shared with us about how they burned in the forests. How did they deal with living in a ponderosa pine forest? So a lot of the really specific knowledge, unfortunately, I think, and I'm sad to say this, but I think that most of it's gone in the Southwest, with some exceptions. For example, the Navajo, the Apache people in Arizona, continued to use fire throughout the early 20th century. And so I think there's quite a bit of oral and transmitted traditional knowledge of how to burn forest landscapes in the Apacheria. And there may be here in New Mexico among the Pueblos as well. We just haven't learned it yet. We haven't talked to, I think anthropologists and archaeologists and tree ring scientists and fire ecologists, we haven't worked enough with the tribes to really get to try to learn what other traditional knowledge there may be out there. But again, sadly, I think a lot of it's lost because to do prescribed burning, we know this today, to do prescribed burning takes a lot of skill. And it takes a lot of place-based knowledge, how to burn that slope. How do I burn that little canyon? When do I do it? How do I set fire? What time of year? How large do I make my fire? If I'm gonna do prescribed burning, if I'm gonna do landscape scale, purposeful burning, how do you do that? And frankly, there's a lot more knowledge about that now in our wildland firefighting crews, including the Pueblo crews. I mean, there are many Pueblo crews out there now that know a lot about using fire. And so there's kind of like there's a modern traditional knowledge thing, and there's a gap also between the scientific way and the knowledge of burning today and the historical traditional. So sorry to go on here a little bit at length, but it's an interesting topic. There are places in North America where there's a lot more traditional knowledge, I think, like Northern California. There are tribes there that have continued to burn despite being suppressed, despite really being forced to stop burning. They still were able to. And so there's been a transmission of knowledge. You can go to Australia, and the Aboriginal populations there have a lot of traditional knowledge. Unfortunately, I think there's quite a bit less in many places in North America.
Yeah, and that's obviously a really rich and complicated history that we don't necessarily have the time to dive into in great detail right now, but I really appreciate you touching on it. Well, Eleanor just had one follow-up question, wondering if that ethnographic work that's still underway is going to be finished and released more publicly.
That's a good question. I need to encourage my colleagues to make more of their work published sooner. There are issues about confidentiality, and so I'm not some of the interviews. I'm not sure if they're completely available to the public, but believe there are audio recordings and maybe video recordings of some of the interviews. So yes, I do hope there will be more of that ethnographic work that has been done by our colleagues here at Jemez.
Alrighty, so we're going to kind of pivot away from the oral tradition, questioning with, Jemez Pablo into a question from Jan Willem. And Jan, it's great to see you on. What would be a realistic future desired condition for the tens of thousands of acres that burned on the Pajarito Plateau, and how would we get there? So that might be for the purposes of ecosystem and habitat restoration, water retention, and cultural resource
Yeah,
protection.
yeah. So what's the desired? Well, we need more fire, and the kind of fires that do not blow out the canopy over tens of thousands of acres. We need low severity surface fire. That's what we're lacking. Now with the fuels and the droughty condition, we have way more high severity fire than we can cope with and sustain. What we need are low severity understory burning. And so for me, the ideal would be to have more prescribed burning, more small fire, more fires, but small fires. So literally burning between snowbanks is one kind of vision. Where we're in wetter times, we're in the fall or in the spring when there's snow on the ground, but there are patches of dry. You could do a lot of burning more safely, right? Now, not every year is conducive to that, and so you got to be careful about which year you do prescribed burning, especially in the spring. But in general, I think we have to get to a place where it's safer to do more prescribed burning, and that'll be possible once we get fire returned over a 2 or 3 or 4 cycles. Then the fires can and will burn at lower severity. We see this an example is very few examples of where repeated burning is starting to have an effect on reducing overall severity and allowing fires then to move over larger landscapes. And the example is the Gila wilderness. And in the Gila, they've been allowing fire to burn since the 1970s. And so there are places that have burned 7 times, 7 times. And so there are tens of thousands of acres of tracts of land of ponderosa pine forest there that have had multiple understory burns. And now most of the time when they let fires burn through there, it burns low severity. Now, they've had some high severity burn patches in the Gila too, especially in the high country. But they're having success with allowing fires to burn over the landscape because it's had multiple iterations. So that one desirable end, I think, is to get to a point where we can do that. The the Pyrito Plateau and other parts of the Jemez, we have a huge problem now because the forests are mostly gone. You've had 80-90% of the forest area has been removed. And so now it's going to take replanting, I think, to reforest those areas. And in the meantime, you have shrubs and grasses. So it's going to be a real challenge to reforest a lot of these landscapes, a very complicated one and difficult one.
Yeah, and this is another one of those places where there's so much more to talk about than we have time to discuss today. Some of the considerations that haven't necessarily made their way into mainstream prescribed fire conversations or managed wildfire conversations are the conditions of the soil, what's left behind after a fire moves through. I know that's something that is always on Jan Willem's mind. So if folks would be interested in talking more about that side of it, that's definitely something that we could put out some resources on FactNM to address, some of those more nuanced parts of returning fire to the landscape.
Yep.
So we just have a couple more questions left, just a couple more minutes left. Starting with one from Peggy, and I'm glad you asked this, Peggy. For any other folks who aren't sure, have you found different or unique fire regimes in pinyon juniper as opposed to ponderosa pine?
Yeah, good question. So yeah, PJ, such an interesting type, and it in New Mexico, it ranges all the way from what we call asbestos woodlands. They don't burn. You get lightning strikes on individual trees, and that one tree might burn, but there's so little sparse fuels between the trees that it doesn't spread, except under really, really rare circumstances. So you get that kind of pinyon juniper woodland that's very sparse and almost no ground cover, all the way up to the really high productive pinyon juniper woodlands that are closed canopy, like on the east slope of the Manzano Mountains. And there are places in New Mexico like that, maybe up around Glorieta, where you got like lots of really big pinyons where the canopies are closed and there's shrub understory. And those pinyon juniper woodlands burn like crazy. They burn high severity. They burn high severity fire, canopy fires, right? So all the way from woodlands that don't burn very much to high severity crown fire type. And then in between, you've got pinyon juniper that's kind of mixes with ponderosa pine, where there's like ponderosa pine stringers coming down into the pinyon juniper. And there, in very rare cases, like Ellis margolis has found fire-scarred pinyons and fire-scarred ponderosa pines, and they show the same fire dates. So you can have a PJ woodlands that were, had some kind of a surface fire regime as well. I think that's a little more rare type. They're either like high severity fire regime, standard replacing type, and the productive end to like almost never burn or only burn individual single trees. It's a highly variable fire regime type, pinyon juniper.
Great. Thank you so much for that answer, Tom. So we just have time for one more question. This is asking you to think a little more broadly about, and you've touched on it a little bit with needing to reshift our baseline, our consideration of the baseline conditions, and move into that state of fire inclusion just mentally. But how else can we apply the lessons of this research to our interaction with fire on the landscape today?
Yeah. Yeah. On the shifting baseline phenomenon, I think it's the important thing, and it's maybe the more general kind of take home I hope that people would get from this historical work is the recognition that the forests you see today and the woodlands that you see today aren't necessarily like natural. They're not like they've been that way always. And in New Mexico, especially, there's been so long history of human interaction with our woodlands and our forests, for good and for bad. And people did find a way to live sustainably for hundreds of years in ponderosa pine forests and around pinyon juniper woodlands. I just hope that people won't be afraid of cutting trees. I mean, this is kind of what we see a lot, is the pushback on any use of mechanical tools for thinning, and rather just let it burn. People have manipulated these forests for generations, for good and ill, and there are ways to do it for good, right? But it requires both, treating the fuels with the tools we have at hand, especially including fire.
All right, well, we'll go ahead and wrap it up there. I would invite folks who want to learn a little more about prescribed fire and how we're working to get it back onto the landscape today to join our webinar on December 7th from 2 to 3 p.m. That's going to be with Brian Phillip, who is with New Mexico State Forestry Division, and Sam Berry, who's a colleague of mine here at the Forest Stewards Guild, talking about the New Mexico Certified Burner Program and the All Hands All Lands Burn Team. So thank you again, Tom, so much for taking the time to come on today, for giving this excellent presentation, and I hope everyone digs into those additional resources that you provided to learn more and be exposed to more of your research. So thank you all for being on.
Okay, thank you. Bye, everybody.